6 or carla46. In this session now we will see how we can detect the path. Before doing that, I want to experiment a bit with the polygon that we use. And I'm thinking about, because the triangle was not, I would say, good enough, because especially for the left lens, sometimes it was cutting the starting or the beginning of the left lane, which is not good. And I'm thinking about replacing the triangle with a hexagon, where basically we start like from here, then we go a bit up, then we do the triangle, then we go down. So hexagon, in this case, we instead of 3 points only, we would have 1, 2, 3, 4, 5. So it's also, of course, we have half hexagon, and so which means we need to start from the left bottom corner. Then we would have a point actually at also, in this case, 0, but not the full height. Maybe in this case it would be height over 2. Yep, let's try plus 100 as a first, as a second point. Then we have the middle point, which we had before. Then the next point would be the width. Then this one again. And this should be our half hexagon. So let me check. Oh, not this one, sorry. How that would look like. Okay, we have unfortunately an error. Let's check what is it. Interesting. Is it from the array? So it is indeed from the array. What's wrong here? So this is the first point. This is my second point. That's strange, because I don't see any error. So now let's do it in this way. So 1, 2, 3. Oh, here. This height. And okay, now let us visualize the mask again. Okay, so that is what I wanted to have. I wanted to, yeah, start from there. Now let's see how that would affect our mask. Mhm. It is simple. Yeah, it's better because we actually see this. Maybe if we lower a bit the center, then we would avoid seeing that, but I don't think there's an issue. Okay, so now it's better because we don't miss the starting of the left line. Okay, so as I said, this is up to your innovation. Choose whatever you think it bring better results. And as I also said, you can actually maybe use a machine learning model and avoid all that. But for that, you need to train. And of course, to train, you need to label. So if you have a labeled data, that would be great. If not, it will be hard. Okay, so, right. So what is the next step now? After somehow isolating the region of interest and the lane that we need to process, we need to actually get the geometrical locations consider of these lanes, which means we need to these lanes, they are polynomial curves, right? So they could be straight line and two curves. And what we need to do first, we have a curve on the left side of the car and one on the right side. We need to estimate the model, the polynomial model of these two basically curves. And because if we can do that, first, of course, we can plot things on the scene where we can actually estimate our path. And theoretically, your path is actually, of course, the polynomial curve that is in the middle, which you can actually get it if you average the polynomial coefficients of the left lane and the right lane, or the sorry, curve and the right curve. Okay, and this is what we will do actually in the next steps. In this basically file, you would find something called, or it is a function that belongs to the hold. It's called the lines detection, or your lens detection, sorry. I always, yeah, confuse line and lens. So this takes basically two images. The first image that you get here, actually the masked image that we see or that we processed, and here is the original image because now at the end I want to plot actually the path on the original image, on the raw image. And we see here like some inputs that you might be wondering now what they mean. So we have number of windows, we have a margin, and we have the minimum number of pixels. And this is whether we are drawing windows or not. So let me show you basically the algorithm that we will work on and why it is useful, if it is useful. This file, right? This one. So basically here I'm using Colab, which is Python online notebook. And I want to use it because I want to visualize some steps of the algorithm that we will be using. Now I have stored some images from the Carla scene, and I would like now to upload these images, or at least one of them, because I want to show you the process that we will implement. Maybe let's take some of the images. Yeah, let's now take the first portion of the code. So just now ignore this. I'll talk about later. What we are doing here, we are just importing this OpenCV. We are importing the matplot pyplot library, which is here to show the image because you cannot use CV2 to image show within Colab. So we are just instead of that, we are using the image show that is part of matplotlib. And if I plot this image, I would see not the best image. Okay, so seems that is not the one that I would like to have. So let's actually store new images and view them. And I've done that actually using this loop that you see here. So here I'm just saying that every 100 ticks of the environment, please store an image. And I want to store a specific image here, which is the seg. And if I go to the render of my word object, which is not this one, but that one, this segmentation is the second image that is returned by the HUD rendering. And if I go to this HUD rendering, this one, the second image that we return is the raw image. I don't want now the I don't want that actually. I want to return the mask. So I want to store the mask image. Okay, so I will run it for a while just to get new images. And I recommend this step is basically before uh, implementing everything within the simulator, maybe you need to implement specific algorithm outside the simulator offline. So to do that, you store some sample images and then you can process these images. And of course, if you are using machine learning, you need to store more than sample images. Basically, you need to store many images, and maybe you need also to store the actions that are maybe from the autonomous car here that we see, or from you as a user when you, for example, control this car. So let me see what we if we get now better images or not, or if we get the images that we want. Yeah, this is one, this is two. Okay, okay. So let's take that now then, because these images are not really useful. Yeah, actually 1 to 4, they are quite similar. Okay, so this is basically our image. Um, Now, what we would like to do is first to have what is called sliding windows segmentation. Now, the first step is basically for this sliding windows segmentation is to get what is called the histogram estimation. So what is this histogram and why I would need this histogram? So the idea that basically we have here uh, first starting of the lane, second starting of the lane, and the third starting of the line. Okay, but yeah, so I have to stop this session now because of the size, so I don't want to lose again another recording. I will continue in the next session. Okay.